name is Louise and I am a teacher with Designer Minds. Today we are going to be doing an engineering design challenge. Before we get started, let's have a talk about engineers. So what do you already know about engineers? What do they do? Can you name any engineers? Let's pause the video here and have a chat about what you know about engineering. Engineers design solutions to problems using maths and science. There are many types of engineers. Civil engineers design bridges and roads and dams. Aerospace engineers design planes and space shuttles. Mechanical engineers design tools and machines. There are many other types of engineers. Did you come up with any other engineers? Engineers use the design process, where they start by asking a question, what is it that we need to do to help? Engineers often help people by designing things to help them with day-to-day life. The next thing we do is some research. We try to figure out what design we can create that will help. Once we have an idea in mind, we can create a prototype. A prototype is generally a smaller version of a large-scale item. It is our first test that we will make on our design. Once we have our prototype created, we can test it and see how to improve. Engineers and scientists rarely get it right the first time, and they will always try to improve. So this is why engineers are great problem solvers. Today we will be creating a zip line. What do you know about zip lines already? And what is it that powers the zip line? Pause here and have a quick chat about what you know about zip lines. When you picture a zip line, do you imagine an adventure park where a person is attached into a harness that is attached onto a cable, and then they zip line across from one tree to another? This is one of the most famous types of zip lines, but zip lines have been used for many years to transport people and goods from one place to another. Zip lines are usually based on a slope where one item will begin at the very top of, for example, a mountain, and then the slope will gradually go down to the bottom of the mountain, and this is powered by gravity. Gravity is a force that pulls an item towards the center of the earth. Today we will be looking at the effects of gravity. The first zip line we will create will be parallel to the ground. For example, we can use this wool to show our parallel line. Later we will then create a slope zip line where one end is higher than the other, creating an angle with the ground. So let's imagine a scenario that will help us become great engineers for today. Imagine that you've just arrived home and you have a big shop that you've brought into the house with lots of goodies. When you arrive home, you learn that the river has burst its banks and there's been a huge flood. Shortly after, there is a power cut. You cannot leave your house and go into the streets as there is a big flood, but you've plenty of supplies, so you're going to be okay. You receive a phone call from your grandmother who lives next door. To help us imagine the scenario, we found this picture in the Irish Times of a flood, and you can see the two houses side by side where there are windows that you're going to be looking out reaching across to your grandmother, but it's a bit too far, so we're going to be using a zip line. Your grandmother is looking for candles and some food, and she'd like you to send it over. So your challenge will be to create a container that you can send across on a zip line and that will safely deliver supplies to your grandmother. You'll be testing various materials and designs, and we'll determine which one works best. So as engineers often work with whatever materials they have around them, we are going to be using recycled materials and things that we find around our own house. So for example, for my container, I will be just using a piece of card. You can use anything that you find around your house, or you can choose from this list. Empty milk cartons, empty food containers, used plastic water bottles, empty tissue tubes, empty drink cans, cardboard tubes, styrofoam bowls, plastic cups or bowls, straws, chopsticks, wooden skewers, pencils, pop sticks, pipe cleaners, coffee filters, Lego, or whatever else you find around your house. Next, we will need something to transport across our zip line. This could be a variety of different items: weights, toys, food, clay, stones, blocks, whatever you can find that will fit well into your container. I will be using these blocks. Now let's choose an attachment. For example, you can use one point of attachment or multiple points. In my example, I will be using some cable ties. I will have 2 points of attachment, but you can choose to have 1, 2, or more. Examples of attachments are paper clips, hangers, twisty ties from packaging, hair clips, accessories, plastic laundry hooks, clothes pegs, string, and elastic bands, or whatever you can find that might work. To help us put our creation together, we may need some tools. This could be something like scissors, hole punchers, masking tape, rubber bands, various types of card, tape, markers, or whatever you think might help you with your creation. For the zip line, we can choose either a smooth or a rough zip line. We can test both to see which one will work best with our prototype. The first choice that I am going to make is fishing wire. I will use approximately 2 meters of this material to create my zip line. You can choose any material from fishing wire, string, twine, wool, rope, clothesline, or anything else that you think might work. Now that you have all your materials gathered, it's time to create your device. Your challenge will be to send your items across your zip line without your device breaking. So have a think about how you're going to achieve this and what problems you might come across along the way. It's time to get building. Let's go. Well done, everyone. How did you get on? I hope you had some fun creating your device. So our next challenge will be to change the slope of our line. So at the moment, our zip line is going straight across. So this is our parallel line. To create a sloped line, we are going to raise one of our sides, the starting point. So if we raise our starting point, this will create an angle to the ground and form a slope. Depending on how high we put our slope, this will change the effect of our zip line. So let's go create a slope with our zip line. The materials we use for our zip line will have an effect on how our device will cross. Earlier, I used a smooth zip line, which was fishing wire. Now, I will show an example where I use wool. The reason for trying different materials is that they will have different amounts of friction. Friction is a force generated by two sliding objects. When we think of friction, we might think of our hands moving side by side. And as we do this, this will generate a heat caused by friction. So have a think about your design and how friction will affect your zipline design. If you change the materials on your zipline, how will this affect how your prototype will work? If you have time, change the material you've used for your zipline and see how this affects your device. I hope you had lots of fun today creating your prototype. Today, as engineers, we had a look at gravity and how it affected fueling our zipline. We also saw another force called friction, and we saw how friction was affecting our zipline. If we had a smooth zipline, sometimes our zipline device may have moved a little too fast. Did anybody think to add any cushioning to protect your materials from impact? Then we had our rough material, which for me was wool. And when we used wool, this was creating more friction, and it was sometimes harder to get our device across. What would you do differently if you had a chance to create another device? Well, thank you so much for taking part today. And I hope to see you again at one of our Designer Minds, summer camps, or after schools clubs. Goodbye.